You guys were convinced earlier that y prime prime plus y equals to x. Let's make it interesting. Let's say the e to the x one, right? So that had yp equals to 1/2 e to the x, right? So what's the general solution? Well, last time we learned how to solve, remember last time we learned how to solve y prime prime plus y equals to 0, right? What was the solutions to that? Yeah. Well, let's see here. Let me show you a way we can look at it. Now, I showed you guys operator factoring last time, right? An equivalent story is to just look at the characteristic equation directly. So the characteristic equation, lambda squared plus 1 equals to 0. So this gives me lambda is equal to plus or minus I. So once I have lambdas plus or minus I, that tells me that y1 is cosine x and y2 is sine x. I mean, I know last time I was doing it in terms of, operator factoring, right? So we had like d squared plus 1, right? And I was like, well, okay, so that is d plus I, or maybe d minus I times d plus I, right? And so this gives me solution e to the ix, which is, by the way, cosine x plus I sine x. And then the real and imaginary parts of that are exactly y1 and y2. I beg of you, do not write d equals to I. It hurts me. It's okay to write lambda is plus or minus I. That is fine. Lambda is a polynomial variable, right? D has a specific meaning. It is the differentiation operator. It is not equal to I. Do not write this. Please. They're very similar, but they're not the same. The algebra here, right? Like this is the polynomial, this is an operator. Same, very related, but okay. Getting to the point. What's my general solution? So I find my fundamental solution set, cosine and sine. So I take a linear combination of these guys, and then I simply add the particular solution. And that is it. That is the general solution to this second order non-homogeneous ODE. Yeah.
How will we be able to find a particular solution when it's not obvious?
Fantastic question. How will we be able to find the particular solution? Indeed, that is exactly the question, right? Everything here we know how to do except for how to find the particular solution. There are two methods. One is general, one is limited. So check this out. So this is G, right? We're trying to solve the problem Ly equals to G. Here's a thought. If I could find some operator A, right, such that A acting on G gave me 0, right? And if that operator commuted with L, I guess it doesn't actually have to commute with L, but if I could find such a thing, right, then I could take star, right? If I take A on both sides, that gives me AL. Zero, right? But then this is a homogeneous differential equation. So I have some hope of understanding. I already know how to do that, right? So one way we could do this, let's see here. Let's look at a specific example. So how about y prime prime plus y prime equals to, let's say, x. So what, maybe I shouldn't do x. Let me do something more exciting. E to the minus x. So this is my forcing term. What annihilates this? This a is called the annihilator. Annihilator. So here's the thing. I already know how to solve differential equations, right? And I know that this is the solution to a differential equation. Right? This is coming from lambda equals to minus 1. Or if you want to think about it in terms of differential, or if you like lambda plus 1 equal to 0, right? To more to the point, it's d plus 1. It's a solution of this, right? So choose the annihilator to be d plus 1. All right. So I go back over here. This is d squared plus d acting on y equals to e to the minus x. I just figured out I should make my annihilator d plus 1. So let us annihilate. So d plus 1, d squared plus d, y equals to d plus 1, e to the minus x. The difference between my way of thinking and the book's way of thinking, by the way, you guys, is I embrace operators early and often. The book waits to talk about operators until section 6.3. All of chapter 4 and the start of chapter 6, they're kind of operator free. I am weaving it into the discussion from the outset because to me it is the easiest way to understand everything and how it all goes together. Once you understand operators, everything he says earlier in the book will make sense anyway. If you understand the operator viewpoint, you can derive everything without much work, is my larger point. So this is 0, right? This, well, check that out. This is d times d plus 1, right? So what we have in total is we have d times d plus 1 squared acting on y equals to 0. Well, I know what the general solution is to that homogeneous equation, don't I? Well, I know. Maybe you guys know. I don't know. So this is going to give us y is equal to c1. That gives me lambda equals to 0, right? This gives me lambda is equal to minus 1 2 times. So lambda equal to 0 just gives me the constant function 1 as the solution. Lambda equals minus 1 2 times gives me c2 e to the minus x plus c2 x e to the minus x. The beautiful thing we could prove that when you do this procedure, when you annihilate the differential equation, the general solution to the annihilated problem will be the general solution to the original problem. However, one of the coefficients is not yet determined, or more of the coefficients. Part of this is going to be the so-called homogeneous solution. What's the homogeneous solution here? Like this problem, going back to the start, what's the homogeneous solution? You have lambda squared plus lambda equal to 0. So you have lambda times lambda plus 1 equal to 0. So my homogeneous solution, y sub h as we sometimes call it, is c1 plus c2 e to the minus x. This is the so-called homogeneous solution. So over here, this piece is the homogeneous solution. And whatever's left is the correct template for the particular solution. So the method of annihilators, what it does is it tells you what's the right kind of guess to make for the particular solution. Then what you have to do, right? So we have figured out that yp has the form a x e to the minus x. In order to figure out what that a is, I have to differentiate it and plug it back into the differential equation and see what it is. So like yp prime is what? Oh, yeah, I'm sorry. Yes, it is. I should come up with a more awesome A for annihilator, but I guess I'll use a B since you've pointed that out there, fixed. But yeah, that was conceptually a different A. Sorry about that. That's a very good question. This you can clean up, right? This is B times 1 minus x, e to the minus x, and then differentiate 2 times. I guess it's x minus 2. This is supposed to be a particular solution, which means I can plug it back into my differential equation. So this has to solve, I need to solve yp prime prime plus yp? Yeah, plus yp prime equals to, what was it? E to the minus x. And so putting these in, I've got b times x minus 2 e to the minus x plus yp prime, which was b times 1 minus x e to the minus x equals to e to the minus x. Now, if I've done this right, yes, I've done this right. All right, so if you do this right, the terms like x e to the minus x will cancel. When I say done this right, I mean if I differentiated right, and if I set up the annihilator right. So check it out, like this and this are canceling, and all you're left with is minus 2b plus b e to the minus x. Of course, you can solve that to get that b is equal to, oh, that's too nice. B is equal to 1. Oh, come on. Is it that? Oh, man, so we could have just, well, fine. Anyway, so long story short, general solution, C1 plus C2, e to the minus x, plus x, e to the minus x. What's that?
Wouldn't B not be minus 1?
Oh, thank you. I feel better about my life. Thank you. Thank you, thank you, thank you. Yes, yes, you're right. Minus 2 plus 1 is minus 1. Anyway, I wanted to spend like a good half hour of class working out problems like this. So we're not, this is your first example of it. This is not the easiest kind of example either. All right? Just to reiterate, the algorithm here is you take the problem, you find an annihilator for the forcing function, that gives you a corresponding homogeneous problem. You write down the general solution set, you look at it, you peel off the part of the solution set which is not the homogeneous part. You change the letter from C2 to B because you don't want to do algebra with C2 because it's a pain in the butt, right? You prefer to do B, C, D, so-called undetermined coefficients, and you plug it back into the differential equation and you'll be able to figure out what these specific numerical values are. Because YP is a particular solution. That means it's a specific solution, right? There will not be constants in the particular solution, except like 2, 3, pi. Here there will always be undetermined coefficients. I mean, there'll be arbitrary constants unless initial data is specified, because these allow for all the different myriad of initial conditions which are possible to be given for the second order problem, initial velocity position. To let you know where we're going, this is only going to work if G is what? If G is something that appears in the solution set to a constant coefficient ODE. So this only works for G exponential, sine, cosine, polynomials, products, and sums thereof. For something like tangent, secant, 1 over x, any of your other favorite functions which have not appeared in last lecture, right? Any of those, this won't work. To quote my community college professor, this dog will not hunt. So you need another method, and that's where variation of parameters comes in. Variation of parameters is a general method that involves formulas that are based on the wronskian. So maybe we'll see that next class. Anyway, thanks guys. And again, your homework is pushed back to Thursday because I need to do more of these. Everything else except for 4.5 you can do though. So like don't put, like just put off, like you don't want to put the whole homework off, just you can delay the 4.5 safely if you want. right? Thanks, guys. And Luke, I've got your form.